Hello again, Brian here at AutoShopTeacher.com, and this introductory demo video is about the ASE A8 engine performance testing, and just going to do a little bit of overview of the process of getting ASE certified in the A8 area, and then look at, I believe it's 3 examples of questions, and give you some tips on when you're taking ASE tests, how you can possibly look at questions differently than you maybe would just naturally on your own. With a little bit of coaching can go a long ways. I do offer specialized and individual A6, A8, L1 training where we can meet and study together, and I can help you with the portions or the subjects within each of those tests that maybe you're struggling with. So you have to pardon me, I'm expecting this one to be a little bit longer. I got a glass of water here. Not sure how long this video is going to end up being, but let's get into it here. So starting out with ASE, go to the ASE.com website, and if you work your way through here, there's a lot going on. But you can go to test, or you can scroll around different areas and look at all the information they have. For me, I usually just go to tests and then come on down here to the learn about certification tests. And then in the automotive world, we are dealing with the A series test, right? So here's the test series. And we can come on down to the A series. And when we get down here, we can see A1 through A8. Those are the ones that are required to be master automobile technician. And then there's the newer one that's been out for a few years now, the A9 for the light vehicle diesel. And if you notice, ASE is also now offering these tests in Spanish. So for those of you that maybe Spanish is your primary language, keep that in mind when you're registering. That might help out a lot. But if you come on down through here, then you see you arrive at this study guide, and you can click on this, and it's a PDF document, and it will open up and look like this. And if you scroll on down for this particular topic, we're going to be looking at A8. So you can see that's on page 51. I have another copy open in another tab here. Here's page 51 of the current ASE study guide. And it tells you in terms of percentage of questions that are going to fall into each category, and even the exact number that are going to fall into each category. So you can see general diagnosis is a big one. And then ignition, and then fuel and air, and then emissions, and then down here you can see the other big one, and actually the largest now as this test has evolved over the years, is computerized engine controls. And if you scroll all the way through this, it then breaks down each of those categories. So if you were going to work with a private teacher and consultant like me, we would want to go through these and highlight the ones that are the areas where you feel that you're the weakest. Because if you have areas you already know, then if we start working together, we just need to fill in the gaps so then that you have that good foundation of knowledge. So look through all of these, and that's where you'll be able to come up with your strengths and your weaknesses. And as with most things that we want to improve, focus on those weaknesses and developing greater knowledge in those areas. And if you continue on down through this, I'm not going to use these examples, but there are some sample questions down here. Okay, so let's go back to my little presentation. And here we are, advanced, not advanced, this is not L1, A8 engine performance. And just going to go through a few questions here and give you some tips, not only on the subject, but on how to take the test, or maybe ways to think about the test that you haven't previously. So here we go. Let's try some sample questions. After performing a wet compression test, the pressure in each of the cylinders increased, but remained below specifications. Okay, so there's our statement. Now we have technician A is going to say one thing, and technician B is going to say something. So when you have these Tech A, Tech B type questions, remember you're answering two questions. So just start with A and figure out, is A right or wrong? And there's half your answer then to the whole question. Then go and figure out what B says, and you have the other half of your answer. So you don't have to try and figure out A and B at the same time. Just figure out if A is right or wrong. Then once you have your answer there, figure out if B is right or wrong. Because possibly they're both right and possibly they're both wrong. Okay, so keep that in mind. Another tip that's helpful for some people, especially if you get hung up on this whole A-B thing, give them a name. I'm a middle-aged white guy, so, Adam and Bob. Tech A is Adam and B is Bob. All right, so if we read now what Tech A, so we're going to say, Adam says this is caused by incorrect valve timing. All right, let's go back to our sentence up here. After performing a wet compression test, the pressure in each of the cylinders is increased, but remained below specification. Okay, so Adam here, or Tech A, says this is caused by incorrect valve timing. Okay, think about that. Think valve timing is causing this low compression issue, and if it was, would adding some oil to the cylinders, wetting the cylinders, would it then change if it was incorrect valve timing? Let's move on to B, okay? Technician B says this is caused by worn piston rings, okay? Technician Bob B says worn piston rings, the pressure in each of the cylinders to increase when performing a wet compression test. Bob is saying if the rings are worn, adding oil to the cylinders, cycling the engine through, and then reperforming that compression test, it's going to go up. The compression is going to be up, okay? So before we get into the answers, I want to ask you a question. When would you be performing a wet compression test? What have you probably done right before that? A traditional compression test, right? And it was low, obviously, okay? Even after the comma up here, it says even after the wet test, it still remained below specification. But you're usually performing a wet compression test because you've already determined it's low compression. You're now trying to determine whether or not pulling the cylinder heads is going to be worthwhile to the, beneficial to the customer, or whether you should be quoting a rebuild or a long block, right? So that's why we would typically be doing a wet compression test, is after we've already done a traditional compression test, maybe even a leak down test, okay? Let's look at our answers. I gave you enough time there while I was rambling on. Hopefully you have your answer. Technician B, or as I call him Bob, is correct, okay? Why was technician A wrong? Well, I kind of already mentioned this in my leading statements I was making on the previous slide. If it were valve timing that was causing this low compression issue, adding oil probably wouldn't have changed anything, because the timing's still going to be in the same out-of-time state. Technician B is correct, but if you'll notice in that question, I'm going to jump back to it, but remained low. Let me jump back to the question. Oh, wait, it's up here still, sorry. But remained low, remained below specifications. That's relevant information, but it's also distracting information. So stick to the main part of the information you're given. Wet compression test, pressure in each of the cylinders increased. And we have one more comma there, but it remained below specifications. Okay, that's all great, but the main part of the information in that question is the cylinder pressure compression increased during the wet test versus the traditional test. Okay, again, remember the reason why you would be doing this particular test. Obviously, this is an imaginary vehicle. This is just a test that we're taking to demonstrate our abilities as technicians. But the type of test that the question is even discussing is important to remember. Why would we be doing that test? Why would we be doing a wet compression test? All right, let's move on. A vacuum gauge is connected to a port on the intake manifold of an engine with poor performance. So we know what test we're doing. We're doing a vacuum test, okay? We know where we're connected. We're not hooked to ported vacuum. We're hooked to manifold vacuum. Okay, it's a port on the intake manifold. And we know that the engine has a poor performance issue. So we know what test we're doing, why we're doing it, and how we have the gauge connected. All right. The needle on the gauge bounces between 15 inches and 20 inches of vacuum at idle. So now we also know the engine is idling. So the engine starts and runs. When you go drive it, it has poor performance. Okay, we know what piece of equipment we have hooked up and where. Now, finally, to the question. This vacuum gauge reading indicates. So we have 4 choices here of what this bouncing needle indicates at idle, bouncing between 15 and 20 inches. Our choices are a normal condition, late ignition or valve timing, a burned exhaust valve, a restricted exhaust. Okay, so we know our reason is we're doing this test because of performance. We know that we're trying to figure out and answer this question about the gauge bouncing. Okay, so let's start eliminating some of these answers. Okay, does this sound like a normal condition? I'm going to jump straight to saying no. Normally we should have a nice steady vacuum. What about restricted exhaust? This engine is idling, okay? Remember, right over here, 15 to 20 inches at idle. So we know it starts and runs and it idles. There is much lower exhaust flow when an engine is idling. If up here in the conditions of this test, it said we were doing this test at 2,500 RPM or in drive on the road at 30 miles per hour or something, and we started getting weird readings on a vacuum gauge, then maybe we would start getting concerned about restricted exhaust. But this engine is just sitting and idling, and if the exhaust was restricted, wouldn't it be consistently reduced? It's not going to pop, jump around. It's not like every now and then the exhaust unrestricts and unrestricts and then unrestricts and causes the vacuum to jump. So I think we can eliminate A and D pretty quickly here. But what about late ignition or valve timing? Well, similar to our previous question, late ignition or valve timing, if it were either of those, in those 720 degrees of revolution, 2 crankshaft revolutions for all the cylinders to fire all 4 cycles, is it going to be jumping? Or would it be, if there was an issue with ignition or valve timing, would it be consistent with every revolution of the engine? And if it was consistent, would it cause a gauge to bounce? Think about that. Let's now look at C, a burned exhaust valve. Okay, we know our first stroke piston comes down with the intake valve open, and that creates that void and lets the air come in through the intake manifold. Okay, but wait a minute, at that time, on the very first stroke of the four strokes of an engine, four-cycle engine, what if there's a hole in the exhaust valve? Now that piston's coming down, creating that void. Atmospheric pressure is trying to enter in from the intake manifold, but we're at idle, so we know we have a restricted throttle, okay, right? We have a butterfly valve in most engines that's restricting the amount of air that can get around that butterfly, okay? But we have a hole in the exhaust valve if we go with answer C. That would be another place for gases, right, to enter back into the cylinder from out of the exhaust. I think I'm going to go with C. I hope you arrived at the same conclusion. So just real quick, A, nope, not normal. Late ignition or valve timing, nope. It would be smooth even if it did have an issue with ignition or valve timing. C, winner, winner, chicken dinner, yes, cylinder leakage. And D, also, just to reiterate, would be low at higher speeds. You start bringing the engine up, higher RPM, you're going to start seeing decreasing vacuum because the exhaust can't exit the engine. Starts, just for simpleness to say, starts backing up within the engine, and we would start having less vacuum. Technician A says a stuck closed EGR exhaust gas recirculating valve will cause an engine to stumble or stall. Okay, this one they completely broke into two for us. Like I told you on the first one, these Tech A, Tech B, Adam and Bob, if you want to call them that, or whatever names you choose, we literally have two complete individual statements here. So this is a blatant example of how Tech A, Tech B questions are two questions that you have to answer to get one correct answer. So let's just look at them individually. Technician A says a stuck closed EGR valve will cause an engine to stumble or stall. Well, let's start out by briefly talking about what is the purpose of EGR, exhaust gas recirculation. Hopefully you're aware from your previous training and preparation and working in the industry, especially if you're preparing to be an emission control or smog check type of technician, you're hopefully familiar with the basics of EGR, but I'll very briefly go over it. Exhaust gas recirculation, the way it works is by taking spent exhaust gases that have already been through combustion, in other words, what we call exhaust, right? And reintroducing those back into the intake side of the combustion system. So we're intentionally bringing exhaust gas back into the cylinder. But why? You would think, if you haven't studied this, wouldn't that melt the piston, the exhaust is hot, and so on. Well, in reality, because it's exhaust gas that has just exited the cylinder, it is what is considered inert, meaning it's already been spent, meaning that it has a very low amount of oxygen remaining in it. The air coming in through the air filter and induction system and into the engine, well, that's air like we're breathing right now. But exhaust gas has a very low amount of oxygen in it. So by introducing exhaust gas back into the cylinder, it takes and reduces the effective capacity of that cylinder. Because if you completely fill the cylinder with air and add fuel, and you do it perfectly, you would have a 100% filled cylinder, which would be great if you can do that. And then you combust it, right? Compress it and combust it. But if you go and replace 20% of that air, right, meaning the oxygen, with exhaust gas, then you don't need as much fuel because you have less oxygen, right? We have to maintain that balance of fuel to oxygen in order to have combustion. And that is what we're doing with EGR. So We're talking about Tech A, and you got to make sure you read the fine print. Stuck closed. Now, why are we talking about this EGR valve? Tech A is saying it will cause the engine to stumble or stall. Well, it's stuck closed, so it's not introducing any exhaust gases back into the intake system. So I'm going to say Tech A is wrong. All right, moving on here so this doesn't drag on forever. Tech B says a stuck open EGR valve. Okay. Oh, wait a minute. Okay. These guys just hanging out by the water cooler talking about EGR valves, right? Tech B says if it's stuck open, the valve will cause detonation. Who is correct? Okay, so there's our command, if you will, from the test to answer both questions and come up with one answer. Well, I've already voiced my opinion that Tech A is wrong. Let's look into Bob's answer or statement here. The valve is stuck open. Don't confuse what Bob is saying about it being stuck open with what Tech A said about it being stuck closed. They're two completely different statements, okay? Because in this case, you will see at the end here, if you reverse the answer and what Adam was saying about stuck closed and what Tech B, Bob, is talking about stuck open, if you mixed up their statements, you could come up with a very wrong answer to this question, okay? So Bob says stuck open EGR valve will cause detonation. Who is correct? Stuck open will cause detonation. All right, back to talking about the purpose of EGR. I already told you one purpose, which is to effectively reduce the displacement of a cylinder by substituting some of the air with exhaust gases, so then less fuel is burned. What is detonation, though? You got to know what detonation is in order to answer Tech B's statement, whether they're right or wrong. Okay, detonation is when the air-fuel mixture combusts prior to when it was supposed to in the normal timing of the engine, in terms of the ignition timing of the engine, okay? Because this is gasoline, remember, we're dealing with here in this engine. So you could say it's more like when a gasoline engine starts combusting the air-fuel mixture without need for a spark plug, because as you compress air, okay, it rises in temperature. That's why you don't want to ever go out to the corner of your shop where your air compressor is and put your hand up on the head or the top of that compressor. It's going to be very, very hot because it's compressing air. And when you compress air, you take a volume of air and compress it down into a small space, it increases in temperature. Okay? So if the EGR is stuck open and we're inducing a ton of exhaust gas back into the induction side, right, drawing in with what air can get in there with the EGR valve being stuck open, we would be reducing cylinder temperature because we have less air and fuel being burned, so temperature is going to drop, so would not cause detonation, because in fact one of the reasons early on when EGR valves were introduced into automotive engines was, besides emissions control and fuel economy, was also trying to counteract detonation, okay? And don't confuse detonation with pre-ignition. Pre-ignition is when we have something in the cylinder, like something on top of the piston, like some carbon, that gets hot and starts glowing to a hot enough point where the spark plug is igniting part of the combustion, or the air fuel, and that whatever is in there that shouldn't be, or whatever, is causing another source of ignition, and we have two explosions that take place that collide with each other, okay? Pre-ignition being that one that started from that glowing carbon or whatever it might have been, or a metal particle that ended up in the cylinder. Okay, and yet that flame front igniting, and then as the piston reaches close to top dead center, the spark plug igniting the remainder of the air fuel mixture, and we end up with pre-ignition. We're talking about detonation here. This is uncontrolled, meaning untimed. It's a combustion that's happening when it shouldn't be, which would be usually because of excess temperature, incorrect compression, whatever it might be. To get back on track, I'm saying that Tech B, Bob, is also wrong. Okay, closed, well, is closed. EGR is not doing anything if it's stuck closed, like Tech A is talking about. Tech B, if what he says about the EGR valve being stuck open, well, that would actually be helping prevent detonation, not causing it. So in this case, Adam and Bob are both wrong. If you think these through and break them apart, right, remember that the Tech A, Tech B are two questions. When you have four answers, like on that previous question, good chance two of the answers are going to be blatant. You've already eliminated half of them. You're now down to needing to think through those last two. But don't be surprised if you find a question like this where neither of the Tech A, Tech B answers or statements are correct, and you have to go with D. And just remember, you know the right answer if you think it through. Again, I'm Brian Wampler at AutoShopTeacher.com. I hope this was maybe a little bit helpful for you. Feel free to reach out to me if you'd like additional training, and I'd be happy to help. Thank you for watching.